Hey everybody, this is Larry. This is day 25 of the Leetcode November challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's poem. Maximum Subarray. Yeah. I mean this is I'm also changing to Firefox as you may notice. So let me know what you think about that. I think this is a very standard-ish problem. It comes up a lot. I don't know how easy this is to be honest, because it is because the solution that everyone talks about has um, a lot of optimizations built in, and people always talk about it as if it's it's obvious. But to be honest, I don't think it is. It's just that a lot of people internalize a lot of these things and kind of talk about it. But one thing is the contains algorithm is what we'll go over, and then another kind of component of this is that this is dynamic programming, despite what it looks like, right? And the way to kind of think about this is that, um, okay, so the way that to think about this, and I'm going to write it top down. I know that there's a very simple looking solution to this, that is, iteration and use all one space. And of course, I probably, to be honest, already have done that in the past. Yeah, I probably have videos on that in the past, so definitely check those out if you want to go think about it that way. I usually don't click through it to see what I've done in the past, but now it's easy, and I think with this one, I'm almost certain that I did anyway. So with that in mind, keep in mind that this particular problem is symmetric in the sense that you can go forward or backwards, and it's the same thing, mostly by noticing that if you have this array, and you reverse the array, then you go in the other direction, right? So it's symmetric in that way. Not every problem has that property, but at least the beginner ones they do, and I think that transition sometimes people have confusion about, because they just assume that it is symmetric when a lot of problems are not, in fact. But anyway, that aside, we can go over the dynamic idea, right? So and because this is easy and tomorrow is Thanksgiving, I'll try to do a little bit more in depth than I would normally, and this is a dynamic programming on a easy problem, right? So definitely let me know what you think in the comments, whether this is necessary, whether this is good or whatever. So the idea is that, okay, first of all, let's just say we have, we start with this array, and okay, so then we ask ourselves in a very simple way of, okay, let's say we have this number, right? If this is a number in a sequence, what is the maximum subarray of this? Well, assuming that we only care about the suffix now, then we can, so you can maybe write something like this, where, okay, so if length of nums is equal to 0, then you return 0 because there's just no more array. Okay, so then divide and conquer, that's fine. Yeah, this may actually have a weird example, to be honest. But we can go over that in a second. Maybe I can write this a little bit differently though. Yeah. Technically we can get around this, but I think I want to do something a little bit different, which is that if the length of the arrays is equal to 1, we return lengths of 0, right? And the reason is, so the edge case that I'm thinking about is the negative case of if you only have negative numbers, if you're not careful, you would return 0. So that's one thing that I want to caution about. And then the question is, okay, the current number is num sub 0, right? So there are two things we can do, which is that, okay, let's say the two scenarios, right? So let's just say we have get max of num sub, the rest of the array of the suffix. We just say, best is equal to this, right? Well, the two scenarios, right? Which is if best is greater than 0, what happens? If best is greater than 0, then the best thing to return that includes this number would be, that plus this number. Otherwise, if best is 0 or less than that, then we just want to return this number, right? The reason is, hopefully it makes sense. The reason is because The reason is because, this is just greedy in a way, and of course, I use greedy, but dynamic programming does depend on a condition that your subproblems are optimal, and the path getting to those subproblems are optimal, right? And in this sense, there is a greedy optimal solution to get to those paths. And that's basically the idea, is that, okay, if we look at the rest of the suffix and it's greater than 0, then we take it because that would give us a better answer no matter what num sub 0 is. Otherwise, we just return num sub 0 because we don't return that way. And that's pretty much it, to be honest. And then you could just do return get max of nums, right? I think this is okay. Let's see. And also let's just do a negative number. Oh no. I got the first one wrong. How did I get the first one wrong? Oh. Okay. So this is wrong. This is because I wasn't clear about how I want to phrase it, so this is wrong, right? So basically, the way that this is, so what is the question you're trying to ask, right? This function answers, which is that given nums, return the max subarray that contains num sub 0, right? So of course, this is not going to necessarily be the best answer because it might not contain the first number, right? So we can do something like for I in range of n. We can do best is equal to max of best of this. Let's say negative infinity, actually. Negative a big number. All right, let's run it again. So yeah, so that should be okay, but I just was a little bit sloppy in how I want to say it. Of course, if you look at this is going to be O of n loop, and this is going to take O of n time. How do I want to say it? Well, this takes O of n time because if you just follow through, if this number has n elements, then we make one recursive call with n minus 1 element. So then you have, so this is going to, for each item, it's going to take n. For each item, it's going to take O of 1 time. So in total, it's going to take O of n time. And because we have an n loop here, this is going to take O of n squared time. So this is where the dynamic or the memorization comes in, is that you can actually, one thing, right, is that we look at this array. Do we need to pass this in all the time? And that's an optimization that you can kind of, you have experience in, you can think about, is that, okay, the only thing that we care about is the index that is in this number, because the nums array never really change. It's always the suffix of nums array, right? So then we can try to convert the nums array into another way of representing the suffix of nums that is canonical, but also just cheaper instead of kind of reconstructing these copies every time. And of course, if you're familiar with dynamic programming, you'll already know that we can change this to index, say, and then everything else would follow. So if index is equal to n minus 1, then we return num sub index, the last number. So here we get max of index plus 1. This is then the index, and of course, this is just I, right? So we want, again, just to make sure that I don't make any typos or silly mistake. Looks okay. I mean, maybe there's a weird case, but at least we got the base cases okay, right? Okay. So that's the first step. Now, at least instead of taking n squared space, we will only take linear space because, linear space because of the recursion, but you can see that we don't create an array every time we make a recursion, right? So it's definitely better than n squared space, so we already made an improvement here. And then the next step is, of course, memorization. What is memorization? Memorization, there are different definitions of thinking about it. The way that I think about it is that, for every input, you get the same output for the same input, right? So that's basically the idea. So then let's keep a cache array, you know that this index, what is this index, right? Index is going to be a number from 0 to negative n minus 1. So then that's of course n numbers, or n number of possible inputs. So then we can put cache is equal to none times n, where n is equal to length of nums, of course. Let's move that up. And then, as I always like to do it for teaching, I'll have it has cache is equal to force as well. And then here we just do, okay, if has cache of index, we return cache of index. Otherwise, at the very end, well, we have to do it twice, I guess. We can rewrite it a little bit. We can rewrite this, right? We're smart people. Oops, I need the if statement. So something like that, right? And that would make it linear time as well, because now every core to get max is O of 1 instead of O of n, and you only do at most O of n of these. So this is going to be linear time. Yay. Oops. And then this is going to be O of n space because, well, we store one entry for every possible input. So that's just going to be O of n. So of course, if you're already familiar with the solution that everyone tells you about, then you know that you can actually reduce this to O of 1 space by converting it to bottoms up, and then noticing a pattern to further reduce the space, right? And in that, you could probably go back to my older video and check it out. I did that there. Cool. Oh, let me give it a submit first. I forgot to actually submit, so let's actually give it a submit. Hopefully I don't make a silly mistake on an edge case. Okay, cool, 6404. Of course, this is a lot slower even, actually. Don't know what happened there. I don't think okay, I don't know. By the way, yeah, so that's basically the idea. Linear time, linear space is the way that I have it, but you can probably go, I'm pretty sure I did it the other way previously, because I don't usually do. Yeah, so you use Cadane's algorithm and you just do this thing. Yeah, cool. That's all I have for this one. If you're in the States or if you just celebrated, happy Thanksgiving. Thank you for your support all this time. If you're here for a long time, it's been 604 days, as you see, so I'm thankful for that. If not, that's okay. Come join the family. Come hang out in the Discord, and yeah, that's all I have for today. That's all I have for now. Have a great weekend. Have a long weekend or whatever. If not, still have a good Wednesday, I guess, or Thursday. Stay good, stay healthy, to good mental health, and take care. Bye bye.